Hello everyone, welcome to another video, another celestial tour. I hope you had a great Christmas, as it is the best time of the year. Anyway, let's begin. So as you know from my previous videos, matter takes up only 5% of our universe. Stars, planets, trees, buildings, you, me, everything is matter. The rest of the 95% is made of dark matter and dark energy. Now, what if I told you that the exact opposite of what we call matter exists in our universe? This video will be about antimatter, the opposite of normal matter. In 1928, British physicist Paul Dirac wrote down an equation describing an electron's behavior at the speed of light. The equation showed that just like how x squared being equal to 4 has two solutions, positive 2 or negative 2, his equation also had two solutions. One solution would describe an electron, but the other would stay as a mystery, as classical physics states that the charge of an electron must always be negative. That was when Dirac discovered that every particle in the universe has an antiparticle by looking at his equation. For example, since an electron is negatively charged, an anti-electron or a positron would be positively charged. Quarks, in this case, would have antiquarks forming antiprotons that aren't positively charged but negatively charged. 4 years later, in 1932, physicist Carl Anderson took a picture of a particle that had the same mass as an electron but was positively charged, proving the Dirac equation right. Thus, antimatter was technically proven, and in 1933, Paul Dirac won the Nobel Prize, followed by Anderson in 1936. So basically, antimatter atoms would have subatomic particles with the same mass and structure as a normal atom, but with an opposite electric charge. If it helps you, you can think of it as an atom, but from a parallel universe. I mean, hey, there could be a universe where things are made up of antimatter. Now, what you're thinking right now is right. If normal matter and antimatter came into contact, the two would be annihilated in a blast of energy and light. Now, this leads into confusion. During the creation of the universe, if the Big Bang created equal amounts of both matter and antimatter, then how come the universe survived? Shouldn't the equality between matter and antimatter cause our universe to be annihilated? Where is the antimatter? These questions to this day remain a mystery, but scientists still work on trying to understand the nature of antimatter, perhaps by creating it. As you or may not know, CERN, also called the European Organization for Nuclear Research, is an organization headquartered in Geneva, Switzerland, that works on important fields in physics, operating the largest particle physics laboratory in the world. So, how do they create antimatter? Well, it is simply created by the transformation of energy into mass. The high-energy particle collisions create particles and antiparticles. The more the energy is put into the collisions, the more massive the newly created antiparticles will be. The Large Hadron Collider is an example of how CERN creates antimatter through these collisions. But antimatter can't be trapped because of the annihilations that happen. Don't worry though, they're harmless and happen in detectors. So another machine they've used is the antiproton decelerator to trap slower antiprotons, making it easier to observe the nature of an antiparticle. Well, how do they do this? Protons collide with nuclei inside a metal cylinder called a target. It takes 1 million collisions to make only 4 proton-antiproton pairs. The antiprotons are then separated and transferred to the antiproton decelerator using magnetic fields. After they pass through the beam pipes and are trapped, scientists can easily experiment with the antiprotons. As I said, it is very hard to create antimatter. It would take some billion years for CERN to create a single gram of antimatter. And that would happen if they use all of their accelerators. Right now, the total amount of antimatter produced since the beginning of CERN is less than 10 nanograms. You might have heard about how much the cost of antimatter would be. Because of its extremely high energy, the cost of 1 gram of antimatter would be 62.5 trillion US dollars. Keep in mind, that's more than half of the global economy. Antimatter is not a joke. A single contact with any matter, including air, would mean the end of the world. 1 gram of antimatter would be enough to replace a nuclear bomb. Of course, we can use innovative inventions instead of destructive ones. For example, can an antimatter spacecraft be possible? Antimatter propulsion might sound like a science fiction story, but some physicists argue that the testing of antimatter propulsion could be possible in a decade if cost wasn't a problem. By using a magnetic field to guide charged particles from an antiproton-proton annihilation through an exhaust, thrust can be produced in an antimatter spacecraft. powering electricity for the spacecraft. Such a spacecraft would save us travel time. The spacecraft would have a speed of 40% of the speed of light if enough fuel source is used. For example, it would take thousands of years with current technology to get to Alpha Centauri, but only 17 grams of antihydrogen would help us get there in only 40 years. But again, we can only produce a few nanograms of antimatter, so these small numbers still won't be very possible to achieve currently because of our knowledge of science and technology today. Let's see what will happen in the future. Alright, so this is the end of the video. I hope I was able to explain antimatter to you guys and that you guys learned some valuable information about antimatter and how it is made. Thank you for watching, and as always, stay astronomical.